Assalamualaikum warahmatullahi wabarakatuh. Hello all, my name is Rezmha Zevania Aurellianty with the student number is 206130001, Practicum Pharmacy Class D. Alright, in this video I'm going to do some practical experiment which the title is surface tension and interface tension. There are 4 experiments that I'm going to do in this practicum. The first is observing of water surface tension. The second is effect of surfactant on surface tension. The third is observing interface tension. And the last but not least, observing surface tension in capillaries and the function of surfactant to surface tension. Hope you guys enjoy my video of practical experiments and happy watching! Before we start the practicum, I'm going to explain what is the definition of surface tension and interface tension. The first is surface tension. Surface tension can be defined as the force occurring on the surface of a liquid which prevents the expansion of the liquid. This is caused by unbalanced tensile force in the liquid interface. This force can be immediately recognized in the rise of fluid in the capillaries and the spherical shape of a small drop of liquid. The second is interface tension. The tension of interface tension is measured in the boundary plane of two immiscible liquids. This interface tension is important in practical and theoretical aspects of the emulsion problem. Surface tension has a force dimension per unit surface length. Its dyne per centi, or power per unit square, its ERG per centimeter quadrat. This can be calculated by knowing exactly the same force and the opposite force. There are several methods for measuring surface tension, but in this experiment, the simplest method that will be used is the capillary rise method. The next is function and phenomena that occur in the determinant of surface and interface tension. Surfactant can reduce the surface tension and interface tension. How? The decrease in surfactant is occurred through the entirety of surfactant into the water and oil phases. The surfactant has a head that likes water or hydrophilic, so that the head that likes water and the tail doesn't like water or hydrophobic, so that the tail goes into the oil phases. Surfactant absorbed at the air-water or oil-water interface. At the interface, surfactant align themselves so that the hydrophobic part is in air or oil, and the hydrophilic part is in water. The main purpose of the surfactant is to decrease the surface and interfacial tension and stabilize the interface. The next is the surfactant function as sweating agent in the process of mixing salt in liquids, and the surfactant function as an emulgator. The first is as sweating agent in the process of mixing solid liquids. The ability of the surfactant to be used in various ways is influenced by HLB, or hydrophobile lipophile balance, where the greater the HLB value indicates the ability to bind to a high hydrophilic group. At the right side is the surfactant function as an emulgator. There are single emulgator and mixed emulgator. The single one is to emulsify a single substance or similar substance to be stable, and the mixed one is to emulsify the mixture from a suspension. The next is the method that we use in this practicum. It is capillary rise method. The upward force of the liquid to enter the capillary tube is caused by the capillary stress, or caused by the phase tension. It will be opposed by the downward force caused by the gravity. A liquid in a beaker will rise through the capillary tube to a certain height because The strength of adhesion between the liquid molecule and the capillary wall is greater than the cohesion between the liquid molecules. Knowing that the increase in fluid in the capillary tube allows us to determine the surface tension of the liquid. So here's the materials and tools that we need for the practicum. So in this experiment 1, we are going to do an observation of water surface tension. As you can see in this video, I prepared a water in a bowl, and then there are some paper clips that I use. I put a paper clip in upright position, like this upright position, and then see what happens. Why it's drowning? Why the paper clips is we put the upright position is drowning? Because the paper clip is made of a material that has a density greater than the density of the water, so that it becomes drowning if you put it in the upright position. How about the horizontal position? I will put it in the water slowly with a fork, and we will see what happens with the paper clip. As you can see that the paper clip doesn't drowning because this phenomenon occurred due to the presence of water surface tension that cannot be penetrated by the paper clip. Next, I'm going to run the experiment with talc powder. As you can see in the video, I prepared a water in a bowl and some of talc powders. Next, I'm going to pour all of the talc powder that I prepared in this video over the water, like this. And then you can see that the talc powder doesn't drowning. Even when I stir the powder, they are not drowning in the water because there is no addition of a wetting agent or surfactant, which can reduce the surface tension, so that when the water is added to some powder containing several fatty substances, it cannot be completely mixed and the powder granules are destroyed. The next experiment is we are going to do an experiment to see the effect of surfactant on surface tension. In this video, I prepared water in a bowl and some of dish soaps. I will put the dish soaps that I've prepared into the water, like this. And then I will stir them gently without a foam until it becomes a water with the dish soap, like this. Next, I'm going to put the paper clip on the water that already mixed with the dish soap in a position horizontal, and then we will see what happened with that paper clip. As you can see in this video, it's how and why the paper clip is drowning. Even when I put it in slowly and like the previous video, because the soap is contains surfactant which can reduce the surface tension, even when I put the paper clip in a horizontal condition. This is another experiment using a water that already mixed with the dish soap with some talc powders. Now, I'm going to pour the talc powders over the water that already mixed with the dish soap, like this. As you can see that the talc powder is also drowning like the paper clip. It because the soap contains the surfactant which can reduce the surface tension. The next is experiment 3. This experiment is used to observing interface tension. In this video, I am using a water and some cooking oils. Next, I'm going to mix the water with the cooking oil and we will see what happens with this. As you can see in this video, there are two phases, right? It is water and oil. It means that water and oil cannot mix together because it is clear that the phases boundary between oil and water is different because the nature of the molecule is different, where the water molecule is polar, which has two different ends of the charge so that the water attract each other. But the oil, while the oil is sticks to each other, so that they can mix each other and become two phases, water and oil. Next, I am going to mix the soap into the water and oil mixture. And we will see what happens if we put a soap into water and oil mixture. As we know that soap as a surfactant can reduce the surface tension, so that we will see what happens if we put the surfactant into the water and oil mixture. In this video, I'm going to stir them like this. Just stir fast as you can, and then it become mixed together because when you add oil to water, they don't mix with each other, but when you add soap, they can blend together. This is due to the role soap as an emulsifier. When you put the soap in the water that mixed with oil, it will be bound to the water and dissolve it. And then it can help the process of oil dispersion in the water. The last experiment is we are going to observing surface tension in capillaries and the function of surfactant to surface tension. The first, I place the straw perpendicular to the surface of water with a soap, and I allow the liquid to rise up through the straw. And then I mark the level of the liquid in the straw. The next is I'm going to place the straw perpendicular to the surface of the water. And I will allow the liquid to rise up through the straw. And then I mark the level of the liquid in the straw. And the last is the water mixed with oil. Like the previous, I place the straw perpendicular to the surface and allow the liquid to rise up through the straw. And then I mark the level of the liquid in the straw. So, this is a comparison of the result of the different solution between mixture of water and soap, water, and mixture of water and oil. So, it turns out that the result of the ratio of the three solutions, that is, the highest is a solution of water and soap. It because the soap in the water have a function as a surfactant that can reduce the surface tension, so that the water can rise the higher than the water solution and the mixture of water with oil. Okay, I think that's all for my practicum experiment video, and thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.